In this video of maxima and minima, we will understand the local maximum values and local minimum values of a function. In the previous lecture, we have discussed about the maximum and minimum values of a function in the entire domain. In this lecture, we are interested in finding the maximum and minimum values of a function in a small interval rather than considering it for the whole of the domain. Now here is the graph of a function. In this graph, the point A is the highest point on the curve because the ordinate f of A is greater than all other ordinates. However, the point B is not the highest when compared to the point A. But consider a small neighborhood or an interval in the vicinity of this point B. Let the interval be B1, B2. In this interval B1, B2, we find that this point B is higher than any of the points in its neighborhood. Hence, we call the point B as local maximum in the interval B1, B2, and f of B is called the local maximum value. Again, consider the points C and D. We see that C is the lowest point on the curve because the ordinate FC is smaller when compared to the other ordinates. However, the point D, if we consider, it is not the smallest when compared to the point C. But if we consider the small interval D1, D2 in its neighborhood or vicinity, D has the smallest value when compared to the other points in this interval. Hence, we call the point D as the local minimum point or point of local minima, and the ordinate f of D is called the local minimum value. Therefore, we can say that if we consider in this interval the point A is the local maximum point and f of A is the local maximum value. Similarly, take the point P, this is the local maximum in this interval. Then, if we take the point D, D is the local minimum point in this interval and f of D is the local minimum value. Again, if we consider only the point C in this interval, then C will be the local minimum point and f of C will be the corresponding local minimum value. Again, if we take the point T and consider only a small interval in its neighborhood, then E is called the point of local minima or local minimum point and f of E is called the local minimum value. Now that we have understood roughly the meaning of local minimum or local maximum, let us see the formal definition of the local maximum and local minimum. Now the first thing is local maximum value of a function. The definition is fx is said to have the local maximum value at x equal to a if whenever x is near a, f of x is less than or equal to f of a. F of a is a local maximum value for f if there is some epsilon greater than 0, so that whenever x is in the open interval a minus epsilon, a plus epsilon, f of x is less than or equal to f of a. And a is called the point of local maximum and f of a is called the local maximum value of fx at x is equal to a. We will understand this with the help of this figure. So in this graph now, first let us see the point A. Now at x equal to a. Now as said in the definition, f of a will be a local maximum value if there is some epsilon greater than 0 such that the interval a minus epsilon, a plus epsilon, f of x is less than or equal to f of a. Now let us understand this with the figure. In this graph, if we consider the point A and consider an interval a minus epsilon and a plus epsilon, where epsilon is greater than 0 is a small quantity, then we say f of a is the maximum value, in fact local maximum value, and a is the point of local maximum. Again, if we consider the point B in this small interval b minus epsilon and b plus epsilon, then we say f of b is the local maximum value and point B is the point of local maxima in this interval b minus epsilon and b plus epsilon. Now let us see the definition for local minimum value of a function. The definition is f of x is said to have the local minimum value at x equal to a if whenever x is near a, f of x is greater than or equal to f of a. To be much clearer, f of a is a local minimum value for if there is some epsilon greater than 0, so that whenever x is in the open interval a minus epsilon, a plus epsilon, f of x is greater than or equal to f of a. And a is called the point of local minimum and f of a is called the local minimum value of fx at x is equal to a. Let us understand the same with the help of this graph. Now in this graph, now first consider any point, say let us consider the point C here now, and now if we take the interval c minus epsilon and c plus epsilon in the neighborhood of the point C, we say C is the point of local minimum and f of C is the local minimum value. Similarly, the point for the point D in the interval d minus epsilon, d plus epsilon, where epsilon is greater than 0, D is said to be the local minimum point and f of D is called the local minimum value. Again, if we take the point E, similarly, in the interval e minus epsilon and e plus epsilon, for epsilon greater than 0, E is the point of local minima and f of E is the corresponding local minimum value. Hence, we understood the terms local minimum and local maximum. Now, we have a few observations here. The first one is local maximum. The term local maximum can also be called as relative maximum. Similarly, local minimum is also called relative minimum. Observation 2. A function may have more than one local maxima and more than one local minima. This will be clear with the following graph. In this graph, now observe, this function has two local maximum points and there are 3, 1, 2, 3. So 3 local minimum points. Then observation 3. Local maximum and local minimum occur alternately. Let us see this also. In this graph we can see local minimum, then comes local maximum, then comes local minimum, again local maximum and again local minimum in this domain. Observation 4. A local maximum value at some point may be less than a local minimum value of the function at another point. Now, local maximum and local minimum. Literally, maximum should be the highest and minimum should be the lowest. But however, now see this graph. If we observe here, A is the local maximum point and B is the local minimum point. But we see that f of A, that is the local maximum value, is less than f of B, which is the local minimum value for this point. Therefore, local maximum value can be less than local minimum value. Hence, we have understood the local maximum and minimum points and also the corresponding local maximum and minimum values.